Solving systems of linear inequalities. Here's one more example, and we want to graph these two inequalities. So we want to graph. Okay, like we did in the other examples, we want to graph the lines first, and then we want to shade in which side of the lines is going to be our solution. So for this first one, now there's a couple ways to graph the line. You can either make a t-chart, or you can change the equation here, or the inequality, so that it's in slope-intercept form, and then you can graph it from there. So let's do it that way. Instead of using the inequality, first we're going to graph the line 2x plus y equals 4. So we're going to replace the inequality with an equals. And then we're going to use algebra to put this into slope-intercept form. So we need to subtract 2x from both sides. The 2x cancels out over here, and you get y equals, and I'm going to put the x first, because if you'll recall, the slope-intercept form is y equals mx plus b. So we want to put the x term first. So we have y equals negative 2x plus 4. And that will tell us that the slope, or m, is negative 2, and the y-intercept is 4. And now we can graph this line. We can graph the line, and we'll graph it by using the y-intercept. Here's your y, and here's your x. The y-intercept, which is 4. And the slope is negative 2, so you go down 2 and over 1. You can also write the slope as negative 2 over 1, so that you have rise over run. And your rise is negative 2. Well, you can assign the negative to either the rise or the run. Either way, you'll get the same line. But just make sure the minus sign is on one of them, either the top or the bottom. So if you put it on the top, you go down 2, because rise would be negative 2, and then run is going to be a positive 1. So you'll get there. And then you could do it again from there. Rise negative 2 and run 1. And you'll get your line. Now before we draw the line, let's look back at the inequality. And you'll see that it's less than or equal to. And that tells us that the line is part of the solution. So we need to draw the line as a solid line, since it's part of the solution. If it was just less than, we would draw it as a dotted line, because less than would mean that the line isn't part of the solution. But in this case, it is part of the solution, so we'll draw it as a solid line. And then we need to decide which side of that line we need to shade in. And the easiest way to do that is plug in a point that's not on the line. And I always like to use 0, 0 if possible. And we can see that 0, 0 is not on the line. So when we plug 0, 0 in, you get 2 times 0 plus 0 is less than or equal to 4. I'm just plugging in 0 for x and 0 for y into our original equation. So we get 2 times 0, which is 0, plus 0, which is 0. It's less than or equal to 4. Is that true? Yes, 0 is less than or equal to 4. It's less than 4, so it's true. So that means that we shade in on that side of the line where that point is. And 0, 0 is on the left side of this line. So we shade that side of the line in. Okay, now we're ready to graph the second inequality. And first we're going to graph the line 2x plus y equals negative 4. And we need to subtract 2x from both sides, minus 2x. And you get y equals negative 2x minus 4, which means that your slope is negative 2, or you can write it as negative 2 over 1. And your y-intercept, or b, is negative 4. So it crosses at negative 4. That's your y-intercept. And the slope is -2. So we can go either, we can assign the negative to the bottom. So it'd be 2 over -1. Or that's the same thing as -2 over 1. Since we're already at the bottom of the graph here, I'm going to do a +2. I'm going to go up to and then -1. Up to and -1. Just because if I go down to, I'm going off the screen. And we can do that the same way. Now, if you'll notice, the slope for each line, here we are, the slope for the first one is -2, and the slope for the second one is -2. And that tells us that these lines are parallel. We can still graph it, but just know that those lines are not going to cross each other. And when we graph this, notice it's also greater than or equal to -4, greater than or equal to. So we know that it's going to be a solid line as well. Oops. It'll be a solid line, something like that. And now which side of this line do we need to shade in? Well, let's plug in 0, 0, since it's not on the line. 0, 0 is right there. So if we plug 0, 0 into the original equation, we get 2 times 0 plus 0 is greater than or equal to -4. And that means 2 times 0 is 0, plus 0 is also 0. So we get 0 is greater than or equal to -4. Now, is that a true statement? Is 0 greater than or equal to -4? Well, yeah, 0 is greater than -4. So that means that 0, 0 is part of the solution, which means that we shade on that side of the line. Okay, now our solution is going to be everywhere that they overlap, which both of them have an inequality that's either greater than or less than and equal to. So the lines are part of it, and also everything in between the lines. So our solution would include the lines. They include the lines and also everything in between the lines. So that's our solution for this one. And you should be starting to get a good idea of how to graph these systems of inequalities. And so far the examples just have 2 linear inequalities, but you could also add a third one or a fourth one. You could add any number of inequalities and graph all of them, and your solution is going to be where all the shading intersects.